Hello again. We have finished our discussion of limits, so now we are going to start talking about one of the big ideas of calculus, and that is derivatives. So let's get started. What exactly is the derivative when I talk about that? It is a formula that allows you to figure out how fast a function is increasing or decreasing at any given point on the graph of the function. It's basically finding the slope of the tangent line at that point. All right. So on this graph, I want to know what is the slope of the tangent line at x equals 2. So there's the point there where x equals 2. You can see I've got a y coordinate of 0. And there's my tangent line right there. So imagine that the curve is like a roller coaster track, and the tangent line is going to be that like a board or something that you place on that roller coaster track or railroad track or whatever, so that it kind of rests on it, but it's not at a weird angle or anything like that. That would be what we call the tangent line. All right, so I need to find the slope of that tangent line. So I'm going to consider the slope between 2 points because I know how to do that. If I had that function and I wanted to know the slope of the line at x equals 2, I could look at the slope between x equals 2 and x equals 3. And I could use rise over run, delta y over delta x, however you want to think about it. Well, at x equals 2, y equals 0, and then at x equals 3, y is 7.5. So I can say that the approximate slope is 7.5. But looking at the green line compared to the red line, it's really not that close. The slopes aren't that close. So I would need to find something closer. So let's try the slope between x equals 2 and x equals 2.2. Well, again, at x equals 2, y is 0, and at x equals 2.2, y is 0.924. So that gives me a slope, if I calculate it, of about 4.62. And you can see that the green line is a little closer to the red line now. But, I would like to get even closer if I can. So now let's look at x equals 2 and x equals 2.02, finding the slope between those two. So again, at x equals 2, y is 0, and at x equals 2.02, y is 0.081204. And you can see that those two lines, the red one and the green one, they're really, really close. So the slope of the green one is going to be very, very close to the slope of the red one. The slope of the green line is 4.0602. Okay? And it looks like as I'm calculating these and using x's that are closer and closer to x equals 2, the slopes are getting closer and closer to 4. So I would guess that at x equals 2, the slope of the tangent line is 4. Now we're going to be able to do better than guess, but that's coming up in this discussion. Let's talk about limits again, because there was a point to actually discussing the limits. Let's say I have this function, it's f of x, and I want to know the slope of the tangent line at that point. So what I do is I find the slope between that point and a point that is a small distance away. So I'm going to let h represent the distance from the x that I'm at to the next one that I'm using. So the second x value that I'm using will be x plus h. Okay? And so the y coordinate will be f of x plus h. All right, so if I find the slope between those 2 points, it is f of x plus h, which is the second y, minus f of x, which is the first y, over the difference between the x's, x plus h and x. So x plus h minus x. I can simplify that denominator to simply be h, which makes sense because that's what I allowed h to be. H is the distance from one x to the second x. All right. So I want to see what happens as the distance between those x's gets smaller and smaller and smaller until it's practically nothing. In other words, I want to know what happens as h approaches 0. So this is actually what a limit is. Remember that word approaches, we used it all the time when we were talking about limits. So the slope of the tangent line is actually going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. That was that formula we saw in the last slide. So that is actually the definition of the derivative. So, for example, if I want to find the slope of f of x equals x squared at x equals 1.5, first let's find f of x plus h. F of x plus h is going to be x plus h squared, which is x squared plus 2xh plus h squared once I expand it all out. So this limit becomes the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. And I can cross out those x squareds, and I'm left with the limit as h approaches 0 of 2xh plus h squared all over h. And I notice that every term has an h in it, so I can divide the top and bottom by h. Remember, h does not equal 0, it's approaching 0, so I can do that. And I'm left with the limit as h approaches 0 of 2x plus h. Now I can replace h with 0, and I just get 2x. So what that means is the derivative of x squared is 2x everywhere. So if I want to know the slope of the tangent line at any point on that graph, I simply need to double the x coordinate. All right, so since I'm looking for the slope of the tangent line at x equals 1.5, 2 times that is going to be 3. So the slope of the tangent line at x equals 1.5 is going to be 3. Okay. So there's some notation you need to know about because I'm not going to write out the derivative of f of x. One of the notations is f with that little tick mark after the f, and what we say is f prime of x. Okay. Another notation is dy dx, and that looks more like a fraction. You would say dy over dx, but it's more commonly said as dy dx, and it's understood that that's a fraction. Okay, so for example, if I have x squared plus 5x and I want to find f prime of x, meaning I want to find a general formula for the slope of the tangent line, then I'm going to find f prime of x. So f of x plus h is going to be x plus h squared plus 5 times x plus h. And if I expand that all out, I get x squared plus 2xh plus h squared plus 5x plus 5h. So my limit becomes all of that minus f of x, which is x squared plus 5x, all over h. And if I simplify that, the x squareds can cancel, the 5x's can cancel, and I'm left with 2xh plus h squared plus 5h all over h. Again, every term has an h in it, so I can cancel out an h from each of those terms, and I get the limit as h approaches 0 of 2x plus h plus 5. And so finally, I can replace h with 0, and I get 2x plus 5. So the derivative is 2x plus 5 for that function. All right, that is the introductory video for derivatives. If you have any questions, please let me know, and I will see you tomorrow.